You're watching Maths Made Fun and Easy with Ikenna, Maths Teacher. Hello and welcome to another episode of Maths Made Fun and Easy. Today we'll be looking at an interesting topic, the laws of indices. First of all, what are indices? Indices is the plural form of the word index. And a number is written in index form like this. Let's say x to the power n. This is a short form of writing repeated multiplication. What this number means is x multiplied by itself n number of times. So x times x times x times x n number of times. So if you count the number of x here, it will be n. Okay? So for instance, if you want to write, if you write 4 to the power 3, this is a short form of writing 4 times 4 times 4. So 4 multiplied by itself 3 times. If you have 3 to the power 4, this will be 3 times 3 times 3 times 3. So 3 multiplied by itself 4 times. You can see that this is a short form or an abbreviated form of repeated multiplication. So that's what we'll be looking at in this video, the different laws of indices and how we apply them to solve problems in indices. Before we move on, I would like you to hit the subscribe button below this video so that you get notified when I upload interesting and fun maths videos like this that will help you excel in mathematics. You're watching Maths Made Fun and Easy with Ikenna, Maths Teacher. Welcome back. I will now list some laws of indices and give some examples to explain these laws. All right, the first law that we would look at is the multiplication law. Let's say p to the power x multiplied by p to the power y. Now, you can see that these are indices of the same base, right? Now, this is the base of this index, and this is the power or the exponent. Now, when you multiply indices of the same base, all you need to do is to add the power. So this is going to be p to the power x plus y. Make sure they are indices of the same base. So let me give an example. Let's say we have 5 to the power 3 times 5 to the power 4. So what would this give us? This will give us 5 to the power 3 plus 4, which is 7. Easy. The next one would be the division law. If we have p to the power x, divide by p to the power y, this will give us p to the power x minus y. So if you are dividing indices of the same base, all you need to do is to subtract the powers. So an example would be, let's say 5 to the power 6 divide by 5 to the power 7. What would this give us? This will give us 5 to the power 6 minus 7, which is minus 1. 5 to the power minus 1. The next would be, let's say we have p to the power x, and then all raised to the power y. This is very easy. All you need to do is to multiply the powers. So you'd have p to the power x, y. An example would be, let's say 5 to the power 3, all raised to the power 4. So this will be 5 to the power 3 times 4, which is 12. The fourth law, if we have p to the power minus x, what will this give us? Now, when you have a negative power, all you need to do to take out this negative from the power is to invert the base of the index. So instead of having p, we invert it as 1 over p. So this will be 1 over p raised to the power, we can safely remove the negative sign on the power now. So this one where we have 5 raised to the power minus 1, if we want to apply this law, it will be 1 over 5 raised to power 1. That is simply 1 over 5, right? So if I have an example, 5 to the power minus 2, this is going to be 1 over 5 squared. 1 over 5 raised to power 2, which is 1 over 25. All right, the fifth law that I will talk about is when you have raised to power 0. So anything raised to power 0 is equal to 1. Anything raised to power 0 is equal to 1. So if we have, for instance, 5 to the power 0, this will be 1. If I have 3 to the power 0, this will also be 1. All right? And then number 6, which will be our second to the last, if we have p to the power x over y, what would this be? P to the power x over y. This will be the white root of p. Okay, so this denominator in the power will be the root of this base of the index. Then this numerator would be the power. So if you say p to the power x over y, this will be the white root of p raised to power x. The white root of p raised to power x. So for instance, if I have 5, let me use 8. Let's say 8 to the power 2 over 3. What will this give us? This will give us the cube root of 8 all squared. So cube root of 8 all squared. Cube root of 8 is 2, then squared. 2 squared is 2 times 2, which is 4. And finally, if we have an equation like this, let's say p raised to power x is equal to p raised to power y. You can see that the base of the indices are the same, then you can safely equate the powers. So we can say if p raised to power x is equal to p raised to power y, then x is equal to y. All right? If p raised to power x is equal to p raised to power y, then x is equal to y. An example would be 3 raised to power 5. Let's say 3 raised to power p equals 3 raised to power q. Then we can safely say p is equal to q. P equals q. All right. Now, this law is very important, especially when you are solving indicial equations. So remember, when the base of the index on either side of the equation are equal, then you can equate the powers. But make sure that's, of course, if p is equal to 1, then this will not hold, right? If the base is 1, maybe raised to power 7, it's the same thing as 1 raised to power 8, right? P should not be equal to 1. All right. I hope you found this interesting. We'll now move on to take some practice questions in order to apply these various laws that we've learned. You're watching Maths Made Fun and Easy with Ikenna, Maths Teacher. You need to know that problems in indices come basically in two forms, either as an expression or an equation. This is what I mean. By expression, I mean something like, you might see equation like evaluate 3 to the power 2 times 3 to the power 4 divided by 3 to the power, let's say 3. Okay? This here is an expression. But then questions can also come as in form of an equation. For instance, if 2 raised to power x is equal to 8, find the value of x. All right, so this is an equation. By equation, there's always an equal sign in an equation. Okay? While this one, there's no equal sign. So this is an expression. To solve an expression in indices, all you need to do is just remember the different laws of indices that we discussed, right? So in this case, what we are going to apply is the multiplication and division law. And so we would have our answer as 3 to the power. For multiplication, we add the powers. And then for division, we subtract the power. So this is going to give us 3 raised to the power 2 plus 4 is 6 minus 3 is 3. So 3 to the power 3, which is equal to 27, right? Now, for this one, when you are solving equations in indices, what you want to do is see if you can make terms in either side of the equation to be indices of the same base. Once you can do that, you now apply that 7th law that we discussed, right? Where if the bases are the same, then you can equate the powers. So that's what you do whenever you see an equation in indices. So in this case, we can make both of them to be indices in base 2. So 8 as an index in base 2 will be 2 to the power 3. 2 to the power 3. And so because the bases are the same, the powers have to be the same. So we simply say that x is equal to 3. Easy peasy. So this is just basically what we'll be looking at in these practice questions. Either an expression or an equation.
You're watching Maths Made Fun and Easy with Ikenna, Maths Teacher.
Now to question number 1. Evaluate 16 to the power minus 1 over 2. You know how we do it? Attempt the question before watching my explanation. First of all, we need to apply the law where we take out the negative from the power. So this is going to give us, and to do that, we have to invert the base of the index. So instead of 16, it will be 1 over 16. And now we can safely take out the negative from the power. What does power 1 over 2 mean? Remember, the denominator of the power would be the root of the base. So this will be the square root of 1 over 16. And then this numerator, raised to power 1, is still the same thing. So what is the square root of 1 over 16? You know, this square root is both for the numerator and the denominator. What's square root of 1? Square root tells you what will you multiply by itself to get that number. If you multiply 1 by itself, you get 1. So the square root of 1 is 1. What's the square root of 16? What will you multiply by itself to get 16? Multiply 4 by itself to get 16. So the square root of 16 is 4. And so our answer is 1 over 4. I hope you got this.
You're watching Maths Made Fun and Easy with Ikenna, Maths Teacher.
Now to question number 2. Simplify 81 over 16 all to the power minus 1 over 4 times 2 raised to the power minus 1. Now to do this, we have to apply the law of indices that tells us how to take out the negative from the power. And you know, to take out the negative from this power, you have to invert the base of this index. So this will be 16 over 81. All right. So now we can safely take out the negative from the power. And so we have 1 over 4 times, same thing here, the inverse of 2 is 1 over 2. All raised to power what? 1. Good. Now, you know 16 is the same thing as 2 times 2 times 2 times 2, which is 2 to the power 4, right? How about 81? 81 is 3 times 3 times 3 times 3, which is 3 to the power 4. Now, all these raised to power 1 over 4. Then times, of course, anything raised to power 1 is still that thing. So this will be times 1 over 2. Now, this power 1 over 4 is both for the numerator and the denominator. So I can write this as 2 to the power 4 times this power, right, over 3 to the power 4 times this power as well, because it's both for the numerator and the denominator. Then we have times 1 over 2. 4 we cancel 4. 4 we cancel 4. So we have 2 over 3 times 1 over 2. 2 over 3 times 1 over 2. 2 will go into 2, and we are left with 1 over 3 as our answer. So our answer is what? 1 over 3. I hope you got this.
You're watching Maths Made Fun and Easy with Ikenna, Maths Teacher.
We now move on to question number 3. I hope you've subscribed to this YouTube channel. If you haven't, why not subscribe so that you get interesting and fun maths videos like this that will help you excel in mathematics. Simplify this expression. All right, so we are multiplying and then dividing. Now, to apply the multiplication and division law, you know that the indices have to be of the same base. But in this case, they are not in the same base yet. But we can express them in base 3, 27, and 9. So we would have this as 3 to the power minus 5n times, now I want to express 27 as an index in base 3. That would be 3 to the power 3, right? So 3 to the power 3, then times n plus 1. Okay? Over 9, I can write as 3 to the power 2. 3 to the power 2, then times 1 minus n. All right, because of space, we would be skipping some steps, but I will see them before we skip them. So we would have 3 here to the power minus 5n, then times 3 to the power 3n plus 3. I'm opening these brackets, right? 3n plus 3. Now, since they are indices of the same base and you are multiplying, you can add the powers. So instead of writing this, I'll just write it as, I'm adding the power now, 3n plus 3. 3n plus 3. Okay? Divide by, here at the denominator, we have 3 to the power, I'm opening the bracket, 2 minus 2n. 2 minus 2n. You know how you open brackets, right? Okay. So now we have indices of the same base and you are dividing. So you do what to the powers? You subtract the powers. So this is going to give us, let me write it here, 3 to the power minus 5n plus 3n. Minus 5n plus 3n is minus 2n. Then plus 3, then minus, I'm subtracting the power of the denominator. 2 minus 2n. You can see how I put this in the bracket, because if I didn't, then this sign here will not change and it will affect the answer. So I have to put this in the bracket because I'm subtracting everything, all this power. Good. So we'll now have this as 3 to the power minus 2n plus 3. I'm opening the bracket now. So this will be minus 2 minus 2n. That will be plus 2n. Good. So for the powers, minus 2n plus 2n, what would that give you? Is 0, right? Same thing as saying 2n minus 2n. So that will be 0. So I can clean this out. I'm doing this because of space. 3 minus 2 is what? Is 1. So we have our power as 3 minus 2, which is just 1. Answer is now 3 raised to power 1, which is equal to 3.
You're watching Maths Made Fun and Easy with Ikenna, Maths Teacher.
Now question number 5. Simplify this expression. 36 raised to power 1 over 2 is the square root of 36, right? So square root of 36 times, we have to take out this negative from the power by inverting the base of the index. So instead of 64, it will be 1 over 64 raised to the power 1 over 3 times anything raised to the power 0 is 1. So 5 raised to the power 0 is 1. What is the square root of 36? You ask yourself, what will you multiply by itself to get 36? You multiply 6 by itself to get 36. So the square root of 36 is 6 times 1 over 64 raised to the power 1 over 3. Now you can write 64 as 4 times 4 times 4, which is 4 cubed, right? Raised to the power 1 over 3, then times 1. Now this raised to the power 1 over 3 is both for the numerator and the denominator. So we have here 6 times 1 raised to the power 1 over 3 is still 1, right? Then 4 raised to the power 3 times 1 over 3. 4 raised to the power 3 times 1 over 3. So these 3 will cancel 3. So we have 4 left. So at the denominator, we would have 4 left, then times 1. Of course, anything times 1 is still. So 2 will go into 4, would be left with 2. 2 into 6, that will be 3. So this will be 3 over 2, which is equal to 1.5. Interesting.
You're watching Maths Made Fun and Easy with Ikenna, Maths Teacher.
Now to question number 6. We have an equation. If 8 raised to the power x minus 1 equals to 1 over 4, find x. Remember, when you have an equation in indices, you want to see if you can make terms on either side of the equation to be indices of the same base. We can make them to be indices of in base 2, right? 8 is something as 2 to the power 3. Then multiply by x minus 1. 4 is the same thing as 2 to the power 2. 2 to the power 2, right? Now, you know, we can, or let me just write it here. I'm opening this bracket now. This will be 3x minus 3. You know how you open brackets? This will be equal to, I want to make it to be 2 to the power something. Now, since I've inverted this base, this is 1 over 2, right? And I made it 2. Then the power, I will have to introduce a negative to it. Instead of 2, it's going to be minus 2. Do you understand? Good. So now we have indices of the same base. So we can equate the powers. So this will give us 3x minus 3 is equal to minus 2. So I can take this minus 3 to the right-hand side of the equation. This will be minus 2 plus 3. So 3x will be equal to what? Minus 2 plus 3. That is 3 minus 2, which is 1. So to get x, I'll divide both sides by 3. So our x is equal to 1 over 3. I hope you got this.
You're watching Maths Made Fun and Easy with Ikenna, Maths Teacher.
Now to question number 7. We want to solve this equation on the board. You know, when you are solving equation in indices, like I said, you try to make terms on either side of the equation to be indices of the same base. So, but before that, let me take the denominator to the right-hand side of the equation. So this multiplied by 1, and you know, anything multiplied by 1 is still that thing. So we have 3 raised to the power x plus 3. Okay, now I can write 9 as an index in base 3. 9 is the same thing as 3 squared, right? 3 raised to the power 2. Then multiplied by this power, 2x minus 3. This is equal to 3 to the power x plus 3. So now you can see that the bases are the same. So the powers have to be the same. So I can equate the powers. 2 multiplied by 2x, 2 multiplied by minus 3. So I'm opening the bracket now. This will give us 2 multiplied by 2x is what? Is 4x. 2 multiplied by minus 3 is minus 6. This is equal to x plus 3. So I've equated the powers. So I'll now solve for x. I'll take x to the left-hand side of the equation. We have 4x minus x. Take this minus 6 to the right-hand side of the equation. We have 3 plus 6. 4x minus x is what? Is 3x. This is equal to 3 plus 6 is 9. So to get x, I'll divide both sides by 3. So x is equal to 9 divided by 3, which is equal to 3. So our answer is 3. I hope you got this.
You're watching Maths Made Fun and Easy with Ikenna, Maths Teacher.
And now to the last question in this video. If this is equal to 16 and this is equal to 1 over 32, find the value of x and y. You know how we do it? Pause this video, attempt this last question before watching my explanation. So we have here 2 to the power x plus y is equal to, I can write 16 as an index in base 2. This will be 2 to the power 4. And then here we have, I can express both 4 and 32 as indices in base 2. 4 is same thing as 2 to the power 2, right? So we have 2 bracket x minus y. This is equal to 32 is same thing as 2 to the power 5. So if I want to write it as, if I want to bring this 32 up, then we would have 2 to the power minus 5, right? So the power I have to take a negative since I'm inverting the base of the index. All right, so here we have indices of the same base that are equal. Then the powers have to be equal. So we have x plus y is equal to 4. We can call this equation 1. And then here we have, if I open this bracket, this will be 2x minus 2y. 2x minus 2y is equal to what? Minus 5. You can see the bases are the same. So the powers have to be the same. Let me call this equation 2. So we have the simultaneous equation here. How do we solve this? We can use elimination method by making, for instance, if I want to eliminate x, I'll have to make the coefficient of x to be the same in both equations. So to do that, I'll have to multiply equation 1 by 2. So let's multiply equation 1 by 2. Sorry, I'm multiplying everything by 2, right? So this will give us, because of space, I'll just multiply it straight. This will give us 2x plus 2y, okay? Then 2 times 4 is 8. I'm doing this because of space, okay? Good. So what do? Do we add or do we subtract? If I want to eliminate x, then we have to subtract, right? Because the coefficient of x in both equations have the same sign. 8 minus minus 5. What would that give us? That will give us 8 plus 5, which is 13. Now, 2y minus 2y. That will be 2y plus 2y, which is 4y. 2x minus 2x. That will be 0, right? So we've eliminated x. So to get y, I'll divide both sides by 4. So y is equal to 13 divided by 4. That will be 3 whole number 1 over 4. 3 whole number 1 over 4 is our value of y. What will now be our value of x? So you can substitute y equals 3 whole number 1 over 4 in any of these two equations. Remember that our equation 1 was actually x plus y equals 4. Remember, right? So that was our equation 1. So x, anywhere I see y, I'll replace it with 3 whole number 1 over 4. This is equal to 4. So x will be equal to what? 4 minus 3 whole number 1 over 4, which will give us 3 over 4. So our value of x is 3 over 4, and our value of y is 3 whole number 1 over 4.
You're watching Maths Made Fun and Easy with Ikenna Maths Teacher.
I hope you enjoyed this video. Just a quick recap. We said that we have basically two ways problems come in indices, either as an expression or as an equation. For an expression, you try to apply any of the laws of indices that will help you arrive at the answer. For equation, you try to see if you can make terms on either side of the equation to be indices of the same base. If you enjoyed today's lesson, why not like it and share it so more people get to see this? And if you've not subscribed to this YouTube channel, hit the subscribe button so you get to see fun and easy, interesting maths videos like this that will make you excel in mathematics. Until next time, bye-bye.
You're watching Maths Made Fun and Easy with Ikenna Maths Teacher.